Good morning to all. I'm Dr. Priyadharshini, Professor of BC Department, Rohini College of Engineering and Technology. In today's class, we shall discuss about the code division multiple access. It is also represented as CDMA. So code division multiple access. So it is one of the multiple access scheme. So this method is used for multiple user environment. So because of this multiple access scheme, more number of users can utilize the available channel at the same time. So in case of CDMA, each users are allocated with unique code. So the users are separated by their code, and because of that, all the users can simultaneously transmit their data at the same time as well as at the same frequency. So here we are considering the CDMA system, which uses the direct sequence spectrum. So in this scheme, each of n user groups is given with its unique code. So the code is given by GI of t. So GI of t, where I stands for 1 to n. If I equal to 1, which indicates the code G1 of t, and if I equal to 2, it represents G2 of t and goes on. So for each users, the code is given. So they are the pseudo noise code. It cannot. They are unique code. So the main advantage of this CDMA system is that all the participants can share the full spectrum of resource. That is, the transmission times of different users symbol do not have to coincide. So this is the general block diagram of the CDMA system. So it's here the spectrum modulation is also done. So first of all, the original signal, the message signal is transmitted from the source. That will be a binary data, and then it is given to the modulator. So the modulator, it has two inputs. One is the original signal from the source, another is the carrier signal. So here consider the carrier signal as a cos omega naught t. Next, the signal is get modulated. So the modulated signal is it's acts as a product modulator. So the product of these two signals are generated, and it is given to the, so that signal is spreaded by using the code. So here the PN sequence is generated. So the code GI of t is given. So once again we are using a multiplier. So the multiplier has two inputs. One is the modulated signal, another one is the PN sequence code. So this PN sequence code is generated by the PN sequence generator. So the original message signal, that is the modulated signal, is spreaded by using the code word. So now since the signals are spreaded, so each users are allocated with this code, and next the signal is transmitted through the channel. So in the channel, there may be chances of addition of noise as well as interferences. So along with our original informations, the noise and interference signals may get mixed up, and all the signals are combinedly received by the receiving side. So the receiving side, the signal along the noise is received, and it is despreaded by using the same code. So whatever the sequence generated by the PN sequence generated at the transmitting end, the code word is generated at the receiving end, and the received signal is multiplied by the PN sequence signal, so that the signal is despreaded, and next it is given to the decoder. So whatever the modulation scheme done in the transmitting end, post reverse operation is done, and at the end of the modulator, the added extra data or the signals are unwanted signals are get eliminated, and the original signal is recovered, and finally it reaches the destination. So if there are 5 or 6 messages are get multiplexed, and they will be separated by the codes, and it reaches the destination properly. So here the carrier signal is given as A cos omega naught t. So the output of the data modulator, which is mathematically represented as S A of t, which is equal to A of t into cos omega naught t into phi A of t. So next, it is transmitted through the channel. So for user group 1, and the resulting signal is J of t into SA of t, which is transmitted through the channel. And simultaneously, users from group 2 through n multiply their signals by their own code functions. So each code function is kept secret, and it is restricted to the other communities. So the signal present at the receiver is linear combination of mm, the signals from each users. Therefore, you can neglect the signal delays, and the linear combination is given as G of t, G1 of ts plus G2 of ts, and it goes on up to Gn of ts into Sn of ts. So next, the first stage of the receiver multiplies receiving side, the multiplies incoming signal with the spreaded sequence GI of t. So therefore, the multiplier will yield the desired signal. Therefore, when the signal received signal is multiplied with the GI of t, which is equal to GI of t the whole square into Si of t, and plus it has the undecided signal, so which is G1 of t into G2 of t, S2 of t plus G1 of t into G3 of t into S3 of t, and goes on up to a number of sequences. And finally, the spreaded signal is obtained. Therefore, the first case, spreaded spectrum of the signal, that is spectrum at the input to the receiver, so that the receiving end, the for the entire frequency, both the wanted signal as well as the unwanted signal has the maximum throughout the bandwidth that occupies the maximum power spectral density. And next, it is after despreading the desired disparate signals, the interference signals whose amplitude will be low when compared with the desired signal. So far throughout the spectrum, the signal is the unknown signal is get eliminated, and the needed signal whose strength will be very high when compared with the unwanted signal, so which can be recovered. So here and along with the received signal, the thermal noise is also added. So it is these added unwanted noise components are eliminated by using proper equalization and the filter operation. So by which the unwanted interference signals are eliminated and the desired signal is obtained within the limited bandwidth. Thank you.